Alright, welcome to this new video. This video is in sections of the chapter that we have started, okay? So this video will focus on the product, the inner product, the norm, and the orthogonality of vectors. So before we start, we know from school, we used to compute the norms of vectors, right? We also used to find the inner products of vectors. If you have two vectors, u and v, and all these two vectors are elements of Rn, so the dimensions of u and v is n, then to find the inner product is just the multiplications of the first element of the vector, first element in u times this first element in v, as you can see here, u1, v1, second element times second element in the second vectors, and so on, up to the nth element in the first vector times the nth element in the second vector, okay? So we can also generalize it like this, is the transpose of the first vector times the second vector. All right, if then our u and v, the elements of the vectors are not real, so if they are complex, how can we do that? I know this one is not high school problem anymore. So in this case, the formula is the following. The norm of the vector u and v when u and v are complex, okay? Or when elements of u and v are complex is given by this formula. So basically here, we still have the multiplications of the first element in the vector u times the first element in the vector v, but we have something different here, and that different is the conjugate, the complex conjugate, okay? So u, the overline here represent the complex conjugate. Then we continue, it's just the same as the school case, okay? So this is what we obtain. Generally, the overline is the complex conjugate. I say if I have A plus IB, then the complex conjugate of this is just A minus IB, okay? So it's the same. So if your vector V is a complex, if the elements are complex, then you have to find the conjugate. Every time if you have the real and the imaginary parts, you just have to apply this overline and you obtain A minus IB, okay? Once we understand this inner product, let's move to the norm. What's the norm of a vector? If you have a vector V of dimension n, then by definition, the norm of the vector is just this, the square root of the inner product of vector V and V, okay? So this is simple. And the last concept here is the orthogonality. So if you have two vectors, u and v, and we say that vector u is orthogonal to vector v if and only if their inner product is 0. This is equivalent to u orthogonal, you can say that, to v. All right, let's take some example and see. For our first example, we have two vectors a and b, with a given by this I01 minus r, and b is 2 plus 3i, 1, 7 minus 2i. And the question here is, find the norm of the vector AB and BA, okay? So they are different. They are not commutative. And you see from the result that these two are different, okay? All right, let's go. Let's use the formula. So AB is, if we use the formula, you see here that we are dealing with the complex vectors, okay? So it's u1 times v1. u1 here is I times v1 overline. So complex conjugate, this is 2 minus 3i, right? Plus 0 times 1 plus 1 minus I times 7 minus plus 2i, okay? So if you expand this, you have 2i plus 3 plus 0 plus 7 plus 2i minus 7i plus 2. Okay, so for the real part, we have 3 plus 7 plus 2, this is 12. And for the imaginary part, we have 2 plus 2, 4, minus 7, this is minus 3i. All right, let's look at the second part. So we want to find b comma a, the norm of this. Again, we apply the formula. First element, b, this is 2 plus 3i, multiplied by u1 overline, so complex conjugate of this is minus I, okay? Plus 1 times 0 is 0, and the last one is 7 minus 2i, times 1 plus I. So let's expand this and see. We have minus 2I plus 3 plus 0 plus 7 plus 7I minus 2I plus 2. All right, let's sum up this and see. The real part is 12 and the imaginary part is 3I. What is your conclusion? So you can see that this, in this example, A, B is just B, A conjugate, okay? So this is the conclusion. Let's look at the second example. So for the second example, we have two vectors, x and y, and the question is, are they orthogonal? Is x, y orthogonal? And so we know how to find the orthogonality. The formula is given here. So two vectors are orthogonal if and only if their inner product is equal 0. That's the definition. Then we just have to find the inner product of these two functions and conclude whether they are orthogonal or not. Okay, so let's do that. Inner product of x, y is, so we take first element of this. This is I times 1 plus 2 minus I times 3 minus I minus 7 times 1. Okay, if we expand this, we have I plus 6 minus plus 1 minus 7. So for the real part, we have 6 plus 1 minus 7 is 0. And for the imaginary part, we have I plus 2I. This is 3I minus 3I is 0, right? Conclusion, x and y are orthogonal, okay? So this is what we obtain. That's the conclusion. All right, I'm going to give you the last example. Basically, when you have more than two vectors, okay? If you have a set of 2, 3, 4, 5 vectors, how do you know that the set is orthogonal? You have two things to verify. First, each vector, the norm of each vector should be 1, okay? Second, vectors should be mutually orthogonal. What does that mean? If I have a set of vectors, S, V1, V2, V3, okay? And I want to know whether this set is orthogonal or not. As we say, the norm of V1 must be 1, the norm of V2 must be 1, and the norm of V3 must be 1. This is the first condition. The second condition is that these vectors should be mutually orthogonal. What does that mean? It means that the norm of V1, V2 should be equal the norm of V1, V3 is equal the norm of V2, V3, and this should be 0. So basically, these are the two main steps that you have to verify if the set is orthogonal or not. So that's all for this video. Thank you.